Hello, my name is Castillo, and I'm going to be walking through a West Point MA104 style quality rep using a projectile motion scenario from the 5th problem solving lab on Cop Keating. I'll be walking through each of the 5 steps, explaining the task and purpose of each step while showing the specific process through this specific problem. Before beginning any quality rep, it is important to first read the problem and take note of the important information and data provided. This not only includes certain variables and constraints that we will be using, but also the desired result that we are looking for. In this case, we are calculating the distance that a B-1 bomber must drop a Mark 82 bomb in order for it to hit a desired target, in this case, Cop Keating. We know that this will be a projectile motion, and further reading into the problem description finds the rest of the information that we'll need in order to perform the quality rep. With that, we're going to jump right into the first step of a quality rep, and that is the problem statement. I've already mentioned what it is that we will be solving for, but it is important to explicitly state your desired outcome within your problem statement so that you and others can know exactly what it is that you're trying to find. In this case, we are tasked to determine the lateral distance traveled between the point at which the Mark 82 is dropped and its target, Cop Keating. This will be more important later when we check back to make sure that we've found the right answer. Not necessarily the correct answer, but the right answer. The next step is making the assumptions about our analysis. In our case, we have 2 assumptions. The first is that we assume that equations 1 and 2 are accurate for the calculation of the drop bombs. Equations 1 and 2 referenced later in this video. This is necessary because we could not calculate the time it takes for the distance to drop the bombs, and reasonable because the Mark 82 has been developed to be a fairly accurate munition. Notice that both of these, or at least both of these, will explain a logical assumption, allowing us to make the calculations, something that will be more applicable to real life scenarios and using this kind of analysis elsewhere. The second assumption is that we must assume that the aircraft follows a predictable flight path as seen throughout the rest of this report being a greater paper. In this case, we're only considering a single part of it. This is necessary in order to accurately model the projectile motion of the bomb as well as the distances from Cop Keating. This is reasonable because modern avionics should allow for this type of precision bombing. Again, these are 2 assumptions that we would make that would allow us to say that our calculations are accurate, or at least make the acknowledgement that they will have these shortcomings and constraints because we make these assumptions. Next is formulation, where we essentially state all of our known constants and we assign all of our variables. In this case, we have this list of variables and constraints here, where we're essentially explaining that when we make reference to v sub x, we'll be talking about lateral velocity of the Mark 82 as it's dropped, and given the information from the problem-solving lab description, we know this to be 956 feet per second. We know, or at least assume, that the vertical velocity is 0 feet per second, and we will use the variables x and y as our lateral distance covered by the Mark 82 and the vertical distance covered by the Mark 82 respectively. We're also given that the acceleration due to gravity is negative 32 feet per second, and we will know that at one point we will have to solve for time, as we will see in the next section. Second to last to the entire quality rep is the methodology section, where we explain how we're going to solve the problem. This is also where we make a reference to the equations that we will use and their locations, whether that be in a textbook or from other sources. This section should be written in a narrative style, as this first section explains, so as to explain the process of the analysis instead of only listing the equations used. However, listing these 2 equations is also very important in order for you to make a reference to that textbook process. In our case, the methodology that we will be using is that projectile motion equations will be used to determine x. Remember that that's something that we defined earlier in formulation, the lateral distance that the Mark 82 travels. In order to do so, notice this is our first explanation of the steps that we're going to be taking to solve the answer. Airtime of the Mark 82 must be calculated by equating the vertical distance must be calculated by equating the vertical distance y to acceleration and time using equation 2. A value for airtime is yielded and can be used in addition to the lateral velocity of the bomb in equation 1 to determine the lateral distance between the bomb drop and Cop Keating. This displacement is referred to as x. In our case, this displacement is our answer. These are the two functions or equations that we'll be using, and also note that they're references to the textbook of where they can be found, as well as the textual diction of how they are defined. These are two equations that we'll be using throughout the rest of the quality rep and the next section, which is the results. The results are essentially, as you would expect, the actual problem-solving process itself, in which we go through and we actually write out each of the steps that we were making reference to. In this case, the first step being us finding the amount of time it takes for the bomb to drop and go from the altitude that it is currently at, of 10,204 feet, dropping down to 0 feet, logically. We know that using Mathematica, or at least is how we state here, something that's also important of a quality rep, explaining how that each problem was solved, or how each step was done. We know that using Mathematica and the solve function to find exactly at what point this equals 0, we know that it takes 25.25 seconds. We then follow the second step of our process, in which we input that time value into our function for lateral distance covered, and we get 24,143 feet. We find that to be the correct answer and our answer that we would submit for this quality rep. Note that all 5 sections are lengthy at worst, and while it seems that it does multiply the amount of work that does need to be done, it does show that a more profound understanding of the entire process itself, going through methodology to explain exactly how the steps are being followed and what steps are being taken, formulation to make more sense of the problem so that later reference can be made to other variables and constants that are previously defined, assumptions that allow us to make an understanding and acknowledgement of how accurate our analysis actually is, as well as a problem statement, which, as I mentioned, we would refer back to see if we had actually solved the problem as we plan to, in which case our intent to be determining the lateral distance, in which case we determine that lateral distance to be 24,000 feet. Thank you for watching. I hope this helps answer not only your questions about projectile motion, but also how to go about performing and using quality reps to practice MA104 calculus concepts.